Hello friends. On demand from student side, I have prepared some of the examples, some of the numerical problems on compaction of soil. So this is one of the problem that is often asked in all the competitive examination. From the laboratory compaction test, the data are like this. Maximum dry density MDD is 1.7 gram per cc. Optimum moisture content is given as 16%, and the specific gravity of the soil is 2.7. We have to find the degree of saturation SR, air content AC, and percent air voids Na at MDD. And the second part of this problem, theoretical MDD, so maximum dry density theoretical at optimum moisture content, that is at 16%. So how to attempt this problem? The problem is quite simple. As you can see, MDD is given. So maximum dry density is known to you. So gamma D, as you know, in laboratory compaction test, can be written as G gamma W upon 1 plus E. Now here in this problem, gamma D is known to us 1.7 gram per cc. G is known to us 2.7. Unit weight of water is known to us 1 gram per cc, and therefore the void ratio can be found out very easily. So this becomes G gamma W upon gamma D minus 1. And if we are going to substitute the values and calculate it, Z is known to us 2.7, gamma D is known to us 1.7 minus 1. And therefore, the value of E can be easily computed. So if you calculate this, it is 0.588. This is the value of void ratio. Having got the value of void ratio, now you can use the relationship to find out the degree of saturation. We know that from the relationship, E into SR must be equal to W into G. So friends, here E is known to us. W, the at optimum moisture content, the value of W is also known to us, and G value are known to us. Therefore, the degree of saturation, that is the part 1 of this problem, is degree of saturation will be the moisture content into G divided by E. So the optimum moisture content is going to be 16%, 0.16 into 2.7, and E we have found out as 0.588. So when we calculate the value of degree of saturation comes out to be 0.7344. That is, it is going to be 73.44%. Then, if you want to find out the air content, the relationship between air content and degree of saturation is 1 minus degree of saturation equal to air content. So, when degree of saturation becomes 100%, that is 1, the air content becomes 0. So, here degree of saturation, we know it, and therefore 1 minus 0.7344 gives you the value of air content, that is 0.2656. So this is the value of air content. So we have got air content value. And if you want to calculate the percent air voids, Na, the percent air voids Na can be easily calculated from relationship at MDD. So at MDD, that is gamma D equal to 1 minus Na G gamma W upon 1 plus E is going to be Wg upon Sr. So here we can at MDD we already know the value of void ratio. So you can replace it that E into SR equal to W into G. So W into G divided by SR. Now the values are all known to you. Gamma D is known. So we can substitute that MDD is 1.7, 1 minus Na, 2.7 G value, gamma W upon 1, this is going to be E, and E is already known to us. Therefore, 1 minus Na equal to 1.7 into 1.588 divided by 2.7. So if you calculate 1.7, 1.588, 2.7. This gives you 0.999, and therefore Na, the percentage air voids should be in percentage. If you can calculate, first it is going to be 1 minus, so 1 minus 0.999, this gives you 0.0, 1 into 10 0.1 into 10 raised to minus 3, that means 0.001, right? So this is the value of this. So in percent, Na is percent air voids, and this is if you multiply it by 100, so then it becomes 0.1%. So the first part is over here. So first part is over. This part is over. Now let's go to the second part of this problem. Second part of this problem, if you look at here, you want theoretical. What is required is theoretical maximum dry density. At theoretical MDD, the degree of saturation is considered to be 100%, and percentage air voids will be 0. No air will be there at theoretical maximum dry density, though practically it is not feasible to remove all the air by compaction process. But if you want to find out the hypothetical value, which is called as the theoretical value, so the second part, theoretical MDD, maximum dry density, that is gamma D, is going to be theoretical, is going to be 1 minus Na into G gamma W upon 1 plus Wg upon Sr. Now for theoretical MDD, the value of percentage air void will be 0. This implies the degree of saturation is going to be 1. And therefore, we can substitute all the values to get the gamma D theoretical. So it becomes 1 minus 0, this becomes 1, 2.7, gamma W 1, 1 plus. Now at OMC, that means OMC is 16%, therefore it will be 0.16 into 2.7 divided by 1. So friends, when you calculate it, it is going to be 2.7 divided by 1 plus 0.16 multiplied by 2.7. So this is going to be 1.885 gram per cc. So the theoretical value is much higher compared to the laboratory compaction test of 1.7 because of the fact that all air from the voids are practically removed. So the maximum value theoretical, so maximum dry density is the gamma d max, but it is going to be theoretical, is going to be 1.885 gram per cc. So there is a very standard problem that is being asked in many competitive examinations, and you can all go through this. Thank you very much.